Welcome back to 6-Minute Statistics. In this video, I'm going to begin our journey into the wonderful world of the normal distribution. What are they? How do we use them to answer our questions? And how do we solve them? That's a lot of questions. Let's start with the first one in this video and go from there. You ready? Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Hello again, Mark here from 6-Minute Statistics, and you might notice that I am not sporting my normal black shirt attire. No, my friends, I have a normal distribution t-shirt my sister gave me many years ago. Thank you, Faith. Surprisingly, there's not a lot of occasions where a normal distribution t-shirt is appropriate. However, when you're making normal distribution videos, it's the right time. So I broke it out, and I hope that it'll help you understand the normal curve. Now, I'm going to disappoint you. This t-shirt is not available in the 6-Minute Statistic Etsy store. So sorry. However, this bad boy is. Oh, what? 2 separate sizes? That's right. Visit the store and you too could be drinking from the 6-Minute Statistics coffee mug. Right? It's time to get to work. All right, so enough kidding aside, let's jump into this whole normal thing, shall we? Most people have seen the normal distribution before. You know the one, symmetric, mound-shaped, dare I say, sexy even. All right, maybe that's me, maybe that's a little over the line, but you guys remember 68, 95, 100, right? The empirical rule percentages? Let's think of the empirical rule as our first steps, or baby steps, if you will, into the normal distribution. Now, I've also talked to you before about random variables and told you about 2 very different types. Discrete, the ones that are a lot of times whole numbers and jump around, like the binomial, for instance. And then we've also talked about continuous distributions, those distributions that can be any value at all, and they don't jump. The normal's one of those. It's continuous distribution that has that distinctive bell-shaped look to it. When we say normal distribution, that really defines a family of distributions. And what I mean by that is there are many different normal curves. Just like the binomial, which was described by a value of n, the number of trials sampled, and a value of p, the probability of success, normal distributions are described by their value of mu, or the population mean, and their value of sigma, also known as the population standard deviation. As I change mu and sigma, I get different normal curves. There are literally an infinite amount of normal curves. There's some software available that allows you to find normal probabilities for different values of mu and sigma. However, it's much more common to find probabilities for a single normal curve called the standard normal distribution, or Z distribution. There are both computer programs and, more commonly used, normal probability tables that allow us to find probabilities for different values from this standard normal distribution. When I decided to talk about normal distributions with you, this is the approach I'm going to take. It's the most common approach to teaching normal distributions. The second benefit of teaching it from this approach is that even if you have one of those software programs that allows you to put in values of mu and sigma, you can still adopt this approach. So this style of solving normals works for everybody. Now let's talk about the standard normal distribution. It's the normal curve that has a mean of 0 and a standard deviation of 1. I should tell you that every other normal curve that's out there, any other combinations of mu and sigma, can be solved by running through the standard normal distribution. So the strategy is going to be for us to learn the standard normal distribution really well so that we can use it to solve any normal curve that we're interested in working with. Sounds easy enough, right? Well, not so fast, my friends. Turns out, like the binomial, there's more than one normal table or normal software program out there. There are a variety of probabilities that are given in various forms and fashions. There's 2 main tables, 2 main types of probabilities that we can get. The first are referred to as cumulative probabilities. Let me explain with an example. Shown next to me is the standard normal distribution that's got a mean of 0 and a standard deviation of 1. Suppose I'm interested in a z-value or a z-score of 1.00. The cumulative distribution will give me the probability less than or equal to 1. With continuous distribution, that equal sign really doesn't matter that much, so we can think of it as a less than or equal to, or a less than probability. Both will be the same for the normal distribution. The inside probability table will give us the probability between the z-score we're interested in, the value of 1.00, and the mean of 0. Now, if we're working with a negative z-score, let's say it's a negative 1.00, it's going to again give us the probability between the negative 1.00 and the mean of 0. The inside probability table always keys on the value of 0. Now, because these tables give us unique types of probabilities, I'm not going to cover them here. I'm not going to have enough time. What I am going to do is provide a video that details how to use each of these tables, and hopefully you'll see how connected they are. You really don't need to understand how to work with both tables, but you do need to know how to use at least one of these tables really, really well. It can be your preference, or depending on your circumstance, you may be forced to use a table that you've been provided with. One isn't inherently better than the other, they just provide the same information in different ways. Your knowledge of what the table provides is all that's going to be needed to solve any of the normal probabilities that you're interested in. So are you ready to learn how to use these tables? Click on one of the links I'm providing here to learn how to use either the cumulative table or the inside probability table. That's your next step. What are you waiting for? It's time to get to work.